Question number 9. So let A and B be two non-zero rational numbers. Non-zero means that should not be 0. Okay. Such that A plus 1 by B is equal to 0. Without assigning any numerical value, determine whether AB is positive or negative. So we have to find out whether AB is positive or negative without assigning value. So we should not take any value for A and B to get whether it's coming as positive or negative. No. So without assigning the values, we have to find out. Right. So let me explain. So first you just take what is given. Okay. First you can just take it up. Okay. What is given in the question? So given, okay, A plus 1 by B is equal to 0 is given. Okay. It's very simple. Just take this 1 by B to the next side. So plus 1 by b, it will become minus 1 by b. If I just take a is equal to plus 1 by b, it will become minus 1 by b. Now take this b to this side. So division will become multiplication. So you'll be getting ab is equal to minus 1. That's it. Right? ab is equal to minus 1. Minus 1 means this is negative. Okay. So we can just say that ab is equal to minus 1. Therefore, AB is negative. Okay, therefore AB is negative. Okay, so negative. Now, question number 10. A rational number has terminating decimal expansion whose last non-zero digit occur in the fourth decimal place. Okay, a rational number is terminating, they are telling, having end, and it's having 4 decimal place. And another condition is the fourth decimal place should not be 0, non-negative digits. The fourth digit should not be 0. Show that such a number can be written in the form of p by 10 power 4, where p is an integer and not divisible by 10. That means p is integer and p is not divisible by 10. That is first part. Okay, we'll be completing first part first. Okay, so we have to take 4 decimal part and we have to say that it can be written as a form of p by 10 power 4. We don't know what number it's going to be. So I am going to choose let x is equal to 0 point. They said decimal point. So we can just start with 0 point A1, A2, A3, A4. 4 decimal point. The condition is A4. The last digit should not be equal to 0. Fourth digit should not be equal to 0. Okay. Now we have the decimal number. If you want to convert the decimal into P by Q format, we know that. As we have the 4 decimal part, I have to multiply with 4 0. So I'm just multiplying with 4 0. 1, 2, 3, 4 0 into x is equal to, I'm just multiplying in both sides, 1, 2, 3, 4. Okay, 4 zeros into 0 point A1, A2, A3, A4. Now if you multiply this, so 10, this is 10,000. So 10,000 can be written as, so 10 to the power 4. 10 to the power 4 is, so 10, 1 followed by 4 zeros. Now into x is equal to, if you are just multiplying by 4 0, the decimal will move towards right side 4 place. So it will move up to here, 4 place. So you'll be getting us A1, A2, A3, A4. Now take this 10 power 4 to this side. So x is equal to A1, A2, A3, A4 just divided by, right, 10 power 4. So instead of A1, A2, A3, A4, I am just taking as this is P. P, it can be in any integers. It can be in any integers and divided by 10 to the power 4. Okay, therefore I can just write, so x is equal to P by 10 to the power 4. So I can just write in the form of P by 10 power 4. The condition is P is an any integer and is not divisible by 10. Now So without performing division, determine whether the decimal expansion of 18 by 125 is terminating or non-terminating. So we should not divide 18 by 125. Without dividing it, so we have to identify whether the given fraction, sorry, given rational number is terminating or non-terminating. Okay, so we already learned. So if you want to find out the given rational number is terminating or non-terminating, means we have to check the denominator. If the denominator is in the form of 2 power m into 5 power n, we can say that is terminating. Otherwise, it's non-terminating, repeating. So we are going to check only the denominator. Okay, I'm just taking the denominator as 125. So 125 can be written as 5 power 3. Okay, 5 cube is 125. Right? So 525 is having only the prime factor of 5 power 3. Or we can just write 5 power 3 into 2 power 0. 2 power 0 is 1. Right? If any number can be written in the form of 2 power m into 5 power n, that is having terminating decimal. So it can be written in the form of 5 power 3 into 2 power 3. Therefore, I can say 18 by 125 is terminating. Okay, so denominator can be in the form of, okay, it's in the form of, I can write. So it is, so in the form of, so 2 power m into 5 power n. Therefore, we can just say 18 by 125 is terminating. 18 by 125 is terminating. Okay, terminating. If it cannot be written in the form of 2 power m into 5 power n, that is non-terminating. If you can, means that is terminating. Okay. Next, if it terminates, state the number of decimal place. Okay. Here is terminating. So we have to find out the number of decimal place. After the decimal point, how many decimal point is going to come, we have to identify. Okay. So we have two methods. So one is, okay, one is by doing normal way. So 18 by 125. 18 by 125 means, so I can just make the denominator as 1000. Okay, if I multiply 125 into 8, so the denominator will become, right, 1000. So now 18 into 8, if I just multiply 18 into 8, what will I get? So 18 into 8, I'll be getting 144. Now I can just say 144 means, so before 3 place I have to keep the decimal point 0.144. So after the decimal point, I have 3 decimal place. So number of decimal places 3 we can write. This is by doing the calculation. Without doing the calculation, I have taken the symbol rule for you. So you can just see the rule here. Okay. The rule is the number of decimal place is equal to maximum of m comma n. Maximum of the power, which is having the maximum power, that is the number of decimal place. Here, which is having maximum 3 or 0. So 3 is maximum. Therefore, number of decimal place is equal to 3. We can write. Okay, these are the tips. Is not given in the book. Okay, textbook. You can just note it down. All these tips. Okay, as we discussed the previous question, the same content. Okay. So once again, question number 12. A rational number in its lowest form has the denominator 2 power 3 into 5. How many decimal place will its decimal expansion have? Explain your answer. So we know that number of decimal place is equal to maximum of m comma n. For the rational number whose denominator in lowest form of 2 power m into 5 power n. Okay, so that means here we have to find out the how many decimal place. Okay, so number of decimal place means you have to see the maximum. Here, what is the maximum? So 3 is maximum. So it's going to have 3 decimal part, right? That's it. So we can just write. So number of decimal place. Okay, you can just write number of So decimal place. So number of decimal place is equal to, okay, maximum of, okay, here we have 3 and 5 power 1. You can just take it as 5 power 1. Okay, the maximum is 3. Okay, the answer is 3. Therefore, the number of decimal place is equal to 3 is the answer for this question. Question number 13. Let A is equal to 7 by 12 and B is equal to 5 by 6. Express both A and B in the form of K1 by M, K2 by M. That means you have to make the denominator same. Okay, M, M. We have to make it the same denominator. Where K1, K2 and M are integers and K2 minus K1 should be greater than 6. The condition is K2 minus K1. That is K2 minus K1 should be greater than 6. Using the same denominator M, write exactly 5 distinct rational numbers. They are asking 5 distinct rational numbers lying between A and B, keeping an integer numerator. This is the first part. Okay, I'm just going with the first part. Right, don't get confused with the questions. So they have given K2, K1 and all. The simple concept. Okay, A is given here. So given A is equal to 7 by 12 and so B is given 5 by 6. As both are having different denominator, for finding the rational numbers, I have to make the same denominator. Okay, for that I have to find out LCM. Okay, LCM of 12 comma 6. Okay, LCM of 12 comma 6 is 12 is the LCM. I have to make the denominator as 12 for both. A is already having the 12 as the denominator. So only the thing is I have to make the denominator as 12 for B alone. Okay, so B, I should just multiply with 2. Okay, 6 2s are 12. So 5 2s are 10. If I just multiply with 2, I'll be getting 5 2s are 10 divided by 6 2s are 12. Now I have two numbers. One is A, I can just write it as A is equal to 7 by 12. Okay, comma. Now my B is equal to 10 by 12. First you check whether you can able to find out 5 rational number. After 7, we will be having 8 by 12, 9 by 12. That's it. Only 2 only I am getting it. They are asking 5 distinct rational number. If you want to find out 5 distinct rational numbers, we have to multiply with 5 plus 1. If you want to find out n means n plus 1. That is the formula. So we have to multiply with the next number 5 plus 1. That is 6. Right? So I have to multiply with 6 with numerator and denominator. So 7 by 12. I should multiply with 6 by 6. The next number. Okay. 7 6 are 42 divided by 12 6 are 72. Okay, 42 by 72. Next one, 10 by 12. So 10 by 12, the same I have to multiply by 6 by 6. So I'll be getting 60 by 72. 60 by 72. The condition also should be checked. Now this is my K2, this is my K1. So K2 minus K1 should be greater than 6, right? We can just check it out. K2 minus K1. According to this scenario, K2 minus K1, what I am getting? 60 minus 42. 60 minus 42, I am getting 18. 42, 50, 60. Okay, 18 is greater than 6. Correct? So the condition is applied. Now I can just check the day. I can find out the rational numbers between. They are asking 5 rational numbers. I can just easily find out 5 rational numbers in between these two numbers. Okay, so I'm just writing 5 rational numbers. Okay, 5 rational numbers are 5 rational numbers are, okay, except these two we have to write. So I can just write it as 43 by 72, 43, 44 by 72, 45 by 72, next 45, 46 by 72, next 47 by 72. Okay, 1, 2, 3, 4, 5. Okay, 5 rational numbers we got. This is the first part is over. Okay, hope you can understand this. Okay, this we already done many questions. Now, second part, explain why the condition k2 minus k1 is greater than n plus 1. It's necessary to find n such rational number between the two rational numbers a and b using this method. Okay. Okay, why this condition should be satisfied? K2 minus K1 should be greater than or equal to n plus 1. If you want to find out 5 rational number, we are just multiplying it the next number, right? 6. Why this condition should be applied? Okay, so let me explain. Okay, the number of integers between two rational numbers, for example, if you are taking K1 and K2 are two integers, okay, K1 is K1 is less than K2. That means K2 is greater than K1. The number of integers between these two means K2 minus K1 minus 1. Okay, this is the formula. It's like a formula. How we are getting this rule means, right? On the number line, you just take first number, you're just taking as K1. The last one is K2. So in between, how many numbers are coming means, so K2 minus K1 minus 1 integers are in between these two. Right? For example, if you want to find out rational numbers between 3 and 7, okay, 3 and 10. Okay, numbers between 3 and 10 means 10 minus 3 minus 1. That is a rule. K2 minus K1 minus 1. What is coming? 10 minus 3 minus 1 means minus 4. Okay, 10 minus 4 is 6 we are getting. Okay, let us check how many numbers are in between. We should not include 3 and 10. What are the numbers? 4, 5, 6, 7, 8, 9. So there are 6 numbers. Okay, that's why you can say if you want to find out the numbers between K1 to K2, we have K2 minus K1 minus 1 numbers. Okay, hope you can understand this concept. Now you come to this concept. Okay, come to this question. Now we have to give the explanation. Explain why the condition is necessary. Okay, so we know that in between K1 and K2, okay, there are, we can just write, I'm just writing the answer here. K2 minus K1 minus 1 integers, okay, integers between, so between K1 and K2, K1 and K2. This is the condition, K2 minus K1 minus 1 should be greater than n. Now you just take this minus 1 to this side, okay, minus 1 to this side. So what will come? K2 minus K1, okay, so greater than, so it will become n minus 1, it will become plus 1. Okay, we are getting the condition. Okay, the condition is K2 minus K1, okay, is greater than, right, n plus 1. Okay, that's why we are just multiplying with the next number. If you want to find out 5 distinct rational number, we are just multiplying with 6. If you want to find out 6 rational number, we have to multiply with 7. N plus 1 rational numbers. Okay, so from this you will be understanding. From this example, 3 and 10 means we are having 6 rational number. The formula is K2 minus K1 again minus 1. Okay, so in case we are having any doubt, ask. I'll just explain once again.
Sir, sir, one
Uh,
second, sir.
yes,
This
Amrita.
K, sir, can you explain once again K2 minus K1 minus 1?
Uh, Okay, they are asking why the condition is necessary to be followed. Okay, okay, once again, so if we are taking two numbers K1 and K2, Okay. So K1 and K2 we are just taking means the condition K2 should be greater than K1. Then only this condition is applied. If you want to find out the number of integers between K2 minus K1 means K2 minus K1 minus 1. This is like a formula, rule. How this rule
To
work means,
find
yeah,
the number of integers between them.
uh, that's only. If you are just taking this is K1, this is K2, K2 is greater than K1. How many numbers in between means we have, okay, 5, 4, 5, 6, 7, 8, 9. So there are 6 integers. How we can apply this in the rule? The rule is this, K2 minus K1 again minus 1. So we are having 6. So 6 numbers it will be in between.
Okay, sir.
Right. Okay, now, right, so it may take, if it's taking 5 minutes little late, so just kindly bear with me. So we'll complete. Only 2 more questions. So we'll complete. Okay. Now question number 14. 3 rational numbers x, y, z satisfy x plus y plus z is equal to 0 and xy plus yz plus zx is equal to 0. Show that all the rational numbers x, y, z must be simultaneously 0. So simultaneously means at the same time. At the same time x, y, z should be 0. We have to prove it. Okay, first you just write what is given in the question. So given x plus y plus z is equal to 0. This is, we can take it as first equation. Next is given xy plus yz plus zx is equal to 0. This is my second equation. For proving this condition, I am going to use the algebraic identity. Okay. Algebraic identity, I think you would have learned about this identity. Okay, x plus y plus z the whole square. Okay, x plus y plus z the whole square is equal to x square plus y square plus z square. Okay, plus we have 2xy plus 2yz plus 2z. I am just taking 2 as common. So 2 I take if a common, 2xy plus yz plus zx. Now this is the formula. Now in the formula, I can just substitute the value. Instead of x plus y plus z, I can just take it as 0. 0 the whole square is equal to x square plus y square plus z square plus 2 into. Instead of xy plus y plus yz plus zx, I can just take it as 0. This also 0 from the second equation. Now 0 square is 0 is equal to x square plus y square plus z square. Okay, plus 2 into 0, this is also 0. Therefore, we can just write this as, therefore, x square plus y square plus z square is equal to 0. Okay, when this is possible, each term is 0, then only this condition is possible. Okay, this sum is, okay, the sum is 0 only when each one is 0. X square should be 0, y square should be 0, z square should be 0. Then only we'll be getting as the answer as 0. In case instead of x, y or z any other value, you will not get 0. Okay. So here the condition is the sum is 0. Okay, the sum is 0 only when, okay, only when each one is 0. Okay, only when each one, each term should be 0. That means x square should be equal to 0, y square should be equal to 0, and z square should be equal to 0. If x square is 0 means x is equal to 0, and y is equal to 0, and z is equal to 0. So we have shown that all the rational numbers x, y, z must be simultaneously 0. Okay, therefore we can say x, y, z must be simultaneously 0. Okay, therefore x comma y comma z, okay, must be simultaneously 0. Okay, 0. Once again, what is given condition? X plus y plus z is equal to 0 is given, and xy plus yz plus z x is equal to 0 is given. We are just taking two equation and we are just using the algebraic identity formula. In the formula, you just substitute instead of x plus y plus z is equal to 0, and xy plus yz plus zx in the place is 0. Simplified, you are getting this. When this is possible means each term should be 0. X square, y square, z square. Everything should be 0. Then only you'll be getting answer as 0. If squares are 0, right, x is 0, y is 0, z is 0. So all the numbers simultaneously should be 0. Okay. I hope I made it clear. Show that the rational numbers a plus b by 2 lies between the rational numbers a and b. Okay, I think you would have learned about this. Okay, I have explained in the beginning, right? For finding the rational numbers in between any two rational numbers, we have learned three methods. One is average method. This is the average method formula, right? If a and b is given, we have to add a plus b by 2. We have average method. Second one is making the LCM, making the denominator same. Third one is decimal method. Okay, now this is average method. That's only we are going to prove it. Show that the rational numbers a plus b by 2 lies between the rational numbers a and b. First, I am just assuming. Okay, let us assume a is less than b. Okay, since a is less than b, I am just adding a on both the sides. Okay, add a to both the sides. I am just adding a to both the sides. If I add a this side, a this side, a plus a is 2a, 2a less than a plus b. Next step is just take this 2 to this side. Multiplication will become division. Now a less than a plus b by 2. I am just taking this is first one. Okay. Next, again, since a less than b, again I am just adding b to both the sides. Add b to both the sides. If I add b to both the sides, this will be a plus b. Here b plus b. So b plus b means 2b. Now you take this 2 to this side. If 2 come this side, a plus b by 2 less than b. Now I am just taking this is second. Okay. Now we compare 1 and 2. Here a plus b is less than a. Here a plus b is less than b. Therefore a plus b it will be in between a and b. Hence a plus b by 2 is lies between a and b. Right. So now the last one. Find the length of the hypotenuse of all the four right triangle in the figure 3.14, which is referred to as in the square root spiral. We already learned how to draw the square root spiral for root 2, root 3. I have taught. Okay, they are asking, okay, what is the length of hypotenuse, right? I am just going to find out only one. For only one rectangle, I will be finding the value of hypotenuse. So balance everything, you can try. Right? I'm just taking this as, so if I just take it as A, B, C. Okay, I'm just taking this as A. So B, C. This is forming a right angle triangle. So I can just apply Pythagoras theorem to find out the third side. Here one unit is given. So I have to find out what is the length of this hypotenuse. Okay, I'm just choosing this triangle. I'm just choosing ABC right angle triangle. Okay, in triangle, okay, in right triangle, AC square, okay, hypotenuse square. AC square is equal to AB square, BC square. Okay, AC square only we have to find out. AC square is equal to AB square is 1 square plus BC square is equal to 1 square. So AC square is equal to 1 plus 1 is equal to 2. Now here AC square is equal to 2. Therefore, AC is equal to root 2. AC is equal to root 2. So I can just say this is root 2. Now we got two sides. By using Pythagoras theorem, we can find out this is root 3. Now this is root 4. Now this is root 5. Now this is root 7, root 8, root 9, root 10, root 11. Okay. So we just completed. Okay, all. Now this is nothing but square root spiral.